Welcome to another informative series brought to you by Autruo. The last time, we wrote some set of instructions that were used to control some set of conveyor systems in synchronization with a turnstar using sensor feedback. In today's series, we will be writing some set of instructions which will be used to synchronize the palletizer, box, and pallet conveyor system during box palletizations. Stay tuned. We will be starting off by creating another FB called Palletizer Infeed. And we will also be using FBD here. Here the incoming pallets will be synchronized with the palletizer. So basically, we will be starting off by adding the orbit instruction. Now we'll be using this sensor here called Infeed sensor. So when this sensor is true, the palletizer chain should be energized. So this sensor will be tagged here. This will be latched with the coil that will energize the chain of the palletizer in the forward direction. The orbit instruction will be further in series with the AND bit instruction. This will be tagged to the set of sensors within the palletizer.
So Andrea, when the pallet reaches this sensor here, the palletizer chain that moves in the forward direction will become inactive.
Yeah, Hendrik. Let's download this set of instructions to our simulation, and let's see.
So that sensor is normally closed by default. When the pallets come in contact with this set of sensors, the contact will switch. Perfect.
I will switch on the conveyor and palleting system. Again, this should be in normally open, not closed. It also applies to the previous series at 17 minutes. So I will download it again. I will also need to remove the front sensor contact from the empty pallet to the palletizer block. In the previous iteration of the program, the front sensor was put into consideration. Now the pallet should roll in now. We will be using another network here. The orbit instruction will be in series with the AND bit instruction. The height pallet sensor will be tagged here. This will be latched with local memories called height pallets memories. The AND bit instruction will be tagged to the packed pallet incoming sensor. These instructions will equal to height pallet memories. And I will also be creating another set of instructions. The front and back sensor of the palletizer will all be equal to another local memory. This local memory will be tagged to another AND bit operation. In series with the normal close of the pallet downward elevator. These AND blocks will further be in series with a timer. This timer is set to 2 seconds. The output of the timer will be connected to this set of this flip-flop. Now the first memories that were created, which is called height pallets memories, will be tagged at the flip-flop reset. And the result of this set of instructions will equal the palletizer at the upward direction. Another output will be created which will be used extensively in the program. This will be called upward memories. It will be tagged to this AND bit instruction. And the result will equal the palletizer elevator move to the limit. I will drag the I/O to the factory I/O driver. Now putting all these into perspective. When these two pairs of sensor at the palletizer are active, then the palletizer elevator should move upwards. When the elevator reaches the sensor that is at height, then the palletizer should stop. And I will download all this to the PLC sim. Let's see. Now it works as expected.
I see. The reason for this timer is to allow the pallet to sit properly within the palletizer elevator before it moves upward. Nice.
We will create another FB. This FB will be called a box conveyor. The program here will be written in statement list. In the first network, we will drag a timer here. The input of this timer will be height pallet memories. And the time will be 3 seconds. The output of this timer will be upward conveyor memories, which is a local memories. We will create additional tags for the second conveyor and palletizer inlet belts. In the second network, the or upward conveyor memories equal the emitter 2 box and box conveyor 1. The third network will be and belt conveyor 1 equal belt conveyor 2. The fourth network will be and belt conveyor 1 equal palletizer 1 belt forward.
So when the palletizer elevator is at height, the height sensor will detect the elevator. This will also in turn activates the box conveyors after some minutes.
Yeah, Hendrik. I will now drag the I/O to the factory I/O driver, and I will also download this RPLC sim.
Everything works perfectly.
I will create another FB block. This block will be called box palletization. Here is where the box palletization instructions will be written. Again, we will be using FBD to write our program here. In network 1, we will be using a counter. What this counter does is to count the incoming boxes before the pusher extends. So basically, we will be using this sensor to count the incoming boxes, while this sensor will be used to reset the counter. In our case here, we want a count of 3 boxes. The output of this counter will be in series with the timer, and the output of all this will result into box complete memories. At network 2, the box complete memories will be tagged to a flip-flop. The reset of the flop will be tagged to the push extended sensor, and the output of the flop will be tagged to the palletizer push. The plan is to create a delay before the cylinder extends to push the boxes. I will drag the I/O to the factory I/O driver, and I will also drag the new block to OB1 for program calling. Now I will download the new iterations of the program to our PLC sim.
Andrea, you will need to tag this overall output of the network to the box conveyor. That way, the box conveyor will stop when the cylinder extends to push the box after counting.
Yeah, Laura. You read my mind. I will create an internal memory here too. These memories are in series with this timer. The normally open of these memories will be tagged to the box conveyor. So after this counter, there will be a delay of just under 2 seconds. I will also be adding another timer just at the reset input of the flip-flop. This timer will create a delay of 1.5 seconds before the cylinder retracts. And the results of the instructions will allow the box to fully settle in the palletizer before the cylinder will extend. So just at the time the cylinder is about to extend to push the counted boxes, the conveyor should stop. I will also extend the time of the first timer to 3 seconds. I will download this to our PLC sim and let's see. Now it works. But there is a little adjustment that we might need to do here. That is, the box conveyor should only be active when the cylinder is at rest position. So I will be adding the normally close of this sensor called push limb diffuse sensor at the box conveyor. So, when the cylinder is not at rest position, the box conveyor should not be active. I will add the tag I/O to the factory I/O driver. Then, I will download the new program iteration to our PLC sim.
The box conveyor and the palletizer cylinder are now in synchronization, Andrea. Perfect. Again, in industrial setting. Real sensor would have been used in the case of this sensor. This will make the machine design to be a little bit more cleaner and neater. Perfect once again.
The next thing is to write some set of instructions that will be used to clamp the box, open plates, and in the same vein, move the pallet to the downward position bit by bit or down to its limit. So in network 3, we will be adding another timer. The input of the timer will be tagged to the palletizer plate open. That is the sensor that will detect when the plate is fully open. The output will be tagged to the reset of a counter, while the input of the counter will be the coil of the cylinder. And the count time will be 2. At the output of the counter, another timer will be added. And the result of the timer will reset to the clamping of the box. Just before the box clamping as well, another timer will be added. The result of this will be elevator memory for downward. While here, a local memory will be created which will indicate that clamping and opening operation is currently ongoing. In network 4, the palletizer elevator memories will be in series with another tag. This will equal to the palletizer downward. What we want to achieve here is, we want to either move the palletizer down bit by bit or move it down to the limit. So basically, this set of instructions will be handy. In network 5, we will be creating a local memories for the remaining input of network 4. Another counter will be added. The input of the counter will be tagged to these counters. So basically, this sensor will detect when the plates open and closes as well. And the reset of the counter will be tagged to the sensor that detects when the fully stacked pallet is leaving the palletizer. The result of these will equal a local down count memories. This will be added to the timer of network 4.
So putting all these into perspective, at the second time when the cylinder has extended, clamping action should happen. And it is only when the pack has been clamped that the plate should open and the pallet will be stacked. And after the pallet has been palletized 5 times, then the fully stacked pallet should move down to the limits.
Then this stack count will be reset by the sensor that detects the fully stacked pallet. Perfect.
Now we'll drag these I/O to the factory I/O driver. We will now download this to our PLC sim. Oops. The time for the clamping is too short, likewise the clamping time. We also forgot to add the open plate conditions. So we will add it here. While another timer will now be added for the downward elevator memories. I will adjust the time across. We will be adding these conditions to the box conveyor program. These will further smooth our palleting activities. Something is wrong. There is a need for me to modify the Palletizer Infeed block. This is for the downward limit when the palleting count is reached. I will download this new iteration to our PLC sim. Now let's monitor the written program. The problem still persists. Oops. Let's find the problem. The time is too short here. I will change it from milliseconds to 3 seconds. This should fix the problem. I will now download this new iteration to our PLC sim. Then let's see.
Perfect, Andrea. It is working fine now.
Yeah. I will also like to tag this to a display. That is, the count should be seen here on this mini screen. I will configure this as an integral.
Perfect, Andrea. Please increase the stack count from 5 to 7 layers.
Now I will like to fine-tune my conveyor with respect to the palletizer activities. We will go back to the empty pallet to palletizer block again, and we will be adding another or bit instructions here. This will be tagged to the pallet conveyor 3, and in series with the empty pallet backup memories. Also it will be further series with the height pallets memories. This instruction will equal to the empty pallet backup memories. I will add another flip-flop here. The normally close of the rear sensor with the palletizer will be added here. While the reset will be tagged to the height sensor, the output will equal the coil of the third conveyor. Now, I will have to delete this output instructions, since the third conveyor coil is used here. In network 3, timer will be added here instead of the flip-flop. The idea is to make the conveyor system to stop after some time. The input of the timer will be in series with the backup sensor, and it is further in series with the sensor that will reset the time. In the pallet Infeed block, in network 6, I will add a timer. The timer will be tagged to the height pallets memories. This will equal to the height pal memories with timers. This is meant to create some buffer time before the conveyor will stop. Now this normally close contact will now be added here to the pallet conveyor, while the empty backup memories will be added here. The plan is to make the conveyor system to stop after some period of inactivities or when the pallet is at height. However, the third conveyor is designed to be in run mode by default. The height memories will be tagged to the other conveyor as well, like the turnstar table 2. And all these tagging will be in normally close configuration. I also want a situation whereby the third conveyor that is in run mode can easily be influenced by the emergency stop button. In network 2 of the empty pallet to palletizer block, I will be adding an emergency stop button here. Now when I press the E-stop, the third conveyor will stop. Again, in the box conveyor, I will be adding the contact of the stack count counter. So when the stack count is attained, the upper conveyor will stop as well.
Perfect, Andrea. This stopped the pallet conveyor. And it also stopped the box conveyor when stack count is reached.
What I describe is already taking shape. Perfect.
In the coming series, I will be writing the last set of instructions which will be used to synchronize the downstream conveyor with the palletizer. Hope you have learned something new today. See you in the next one.